All right, today we're diving into something pretty wild. It's a new theory of everything called First Quanta, and it tries to bring all of physics together under one incredibly elegant idea.
And the whole thing really starts with this one fascinating question. What if the universe we live in, this stable, three-dimensional reality, isn't just some random accident? What if it's actually built on the same principles of harmony that we find in music?
So the core idea here is that the space you're in right now, it's not the bottom floor of reality. Nope. This theory says that space itself emerges from something more fundamental, the vibrations of 6 basic strings. Their tones, you could say, literally create the properties of the world around us.
Okay, so how in the world do you get from 6 vibrating strings to the 3 dimensions we all know, length, width, and height? Well, it turns out the answer lies in giving each dimension its own unique harmonic signature. This is just so cool. The theory builds our entire world using the most basic, stable relationships in music. So you have 2 strings vibrating together in unison. That's your x-axis. Then you get a second pair, vibrating in a 3-to-2 ratio. Musically, that's a perfect fifth, and boom, there's your y-axis. The last pair vibrates at a 2-to-1 ratio, the perfect octave, and that gives us the z-axis. The idea is that our reality is built on these super stable, perfectly consonant intervals.
And this isn't just some pretty metaphor. The model actually says that this deep musical harmony is the physical reason our universe is so stable. If the dimensions were based on dissonant, clashing ratios, reality might have just flown apart or collapsed moments after it was born.
So this whole musical foundation, it all builds towards something the theory calls the master equation. Basically, it's proposed central law for how the universe works.
And this master equation kicks things off by totally rethinking what gravity is. It says that the bending of space and time isn't caused by just one thing, like we thought. It's actually caused by 2 completely different things working together.
Now, the first source is one we know pretty well, thanks to Einstein. It's just the warping of space-time caused by the mass of stuff. Planets, black holes, galaxies. That's what keeps everything in orbit.
But here's the revolutionary part, the second source. The theory claims that information itself, the amount of order or chaos in a system, which scientists call entropy, can bend space-time all on its own, without any mass at all. So a highly ordered region of space will have a different natural curve than a chaotic one.
Which brings us to this simple but powerful law. The total curvature of reality is just the sum of those 2 parts. It's a perfect marriage between the physical world of geometry and the abstract world of information.
A new law sounds great, but the real test is, can it actually predict anything? Can it explain things our current models can't? Well, let's see what it's got.
Okay, let's talk about the expansion of the universe. The standard model says it should be a smooth process, but this theory says no. The expansion happened in distinct steps, in stages. And if that's true, it should leave these little periodic spikes in the light from distant galaxies. And guess what? When we look at the actual data from galaxy surveys, those exact non-random spikes are there. We also see how powerful it is in computer simulations. If you model a complex system using standard physics, the total energy tends to drift over time. It's not perfectly conserved. But a simulation built using this theory's rules, it stays incredibly stable. It conserves energy with more than 40 times the accuracy. That's a huge deal. It even gives us a physical reason for one of the weirdest things in quantum mechanics, quantum tunneling. Where a particle just passes through a barrier it shouldn't be able to. The theory suggests this happens because the barrier's entropy can randomly fluctuate. For just a split second, a flicker of pure order can lower that wall just enough for the particle to sneak right through.
So, with these new rules, the theory gives us a totally new history of the cosmos. And it doesn't start with a big bang. It starts with a big pop.
Instead of an infinitely dense point, this story starts with Epoch Zero, a timeless, perfect crystal made of pure information. Our universe began when a tiny flaw, like a bubble of nothing, just popped into existence inside it. Energy from that crystal flooded in, and that kicked off the whole evolution of our universe through all these different stages.
But how does the universe know how to evolve toward more complexity? Well, the model suggests it's a hologram. Every single particle inside our bubble universe is connected to a twin particle on the boundary of that bubble. That boundary acts like a cosmic hard drive, holding the blueprint for reality and guiding how everything unfolds from the outside in.
And here's the kicker. This new origin story is shockingly accurate. It predicts when the first light in the universe should have appeared, what we call the cosmic microwave background, and its prediction is a 99.8% match with our best observational data. That is incredibly precise.
So you put all these pieces together, the musical dimensions, the master equation, the holographic universe, and it all builds to one final, truly mind-bending claim about what reality even is.
At its deepest level, the theory says this: physics and information theory are just two different languages describing the exact same thing. Think about it. A ball rolling down a hill is just following the path of least action. A hot gas cooling down is just organizing itself into a state of minimum entropy, or maximum order. This theory says those two drives, they are one and the same universal law. And that leaves us with one last, really provocative question. If our universe, at its most fundamental level, is a holographic projection, a reality guided by pure information, then it kind of forces you to wonder, in a way that really challenges how we think about existence, what or who is reading the code.